Hello. I have actually two questions. One is related to the recognition of roof PVs. So, the question is, do you use the color pictures like free layers as an input or the grayscale? Because I mean, for the recognition of the solar equipment which is usually installed on the roof, it's either kind of blue or brown. I would really believe that it's maybe the most important feature which influences the results. But also the shape, it's pretty rectangular, or the combination of rectangular stuff. So according just to my experience in computer vision, for that case, especially if you have to label your data manually and to collect them, of course, it takes time. And for convolutional neural networks, you usually need a lot of data. In this case, if the shape is pretty predefined, let's say, and the color as well, I would rather use the OpenCV or any library for computer vision where you use the pattern matching. It could be a much better performance, especially, as I understood, you reported 80% of accuracy on two classes model, right? It's either there is or no, therefore, for two class models, in this special environment, I would say it's not a lot. Maybe just to try out another alternative, except for collecting more data. Or just pay attention, because as I understood, you've got the neural network, which is pre-trained, and only you change the last layer. But just pay attention that the first layers do not, let's say, get rid of the color, that they really treat those layers separately, because for you and for your model, it's one of the important features, just to increase the improvement. Yeah. And another question is to the last talk about the wind turbines. Is it really, I'm just not a big expert in this, is it really like the first turbine can influence, change the speed of the wind that the second one can get less?
Yes, so it's like you have to think about like a shadowing effect, right? So you have a front turbine that is taking the most wind out, and basically the typical control of the wind turbine is that a greedy one. So every turbine tries to get as much as possible from the wind without talking or thinking about what is the impact on the other is. So what we wanted to do is to demonstrate, there are a lot of literature that are based on the simulation, right? That you can reduce artificially the output power from the reverse turbine, which means basically you take out less energy from the incoming winds. You leave more winds to the downstream turbine. And of course, depending where you set the parameters, you can find the optimal setting so that you maximize the power output of the two groups or the two turbines.
But I don't they shift it in any way, because they are pretty, let's say, narrow, I would say, in one direction. Can you just install them that they do not influence each other?
This was in the park layout that I showed. Of course, you try to maximize the distance between the turbines in the prevailing wind direction, but due to economical scale, you cannot really inflate the size of your park because you don't know the length or you reach some limitation. So there will be always some subdominant wind direction where this wake effect will be important, and is estimated, depending on the layout, that could reduce by 5 to 15% the output power of a total wind park. And of course, you can tackle part of this, you have a great gain at the end.
Okay, thanks.
Andreas?
Yeah, my question is for the reinforcement learning with the wind turbines. In terms of the data velocity and volume, what sort of data are you streaming in, and how often? What's the size of the time step that's being used to make a decision on the adjustments?
Yeah, thanks for the question. Actually, I couldn't touch this in the presentation due to time. So basically what we are using here is 30 seconds sampling. And basically to activate the algorithms, you have to take into account the propagation time of the wake. So whenever you start changing something on the first turbine, you have immediately a power drop, right, from the first turbine. But given the velocity, it may take 1 or 2 or 3 minutes for the modified wind flow to reach the second. So you have to take these into account. It's a very dynamic things and depends on the direction. And then you start to integrate basically what is the gain only after or you expect that the modified wake has reached the second turbine. So that's basically part of the things. There were a lot of technical challenges that we had to solve in order to make it possible. Just to comment also on the previous comment that, of course, the algorithm itself is not very sophisticated, but in order to implement it in a real scale and a real environment, it was quite challenging.
Further questions? Yes.
So I have a couple of questions. I'll start with the solar panels one. I was wondering, can you actually improve the performance by using data from the American data sets? So using both data sets and then try to see if you get better performance?
So the idea of not with the pen, but the one we are trying now is to start exactly from the weights of the US solar farm. So we start from this way and try to train the last layer just based on that. This should have to detect the value because it's very pre-trained on the same task. It's the same behavior.
Thanks. And the second question for Martin. So you made this kind of archetypes modeling for thermal loads. Did you do the same for electrical loads as well, for different types of houses or buildings?
No, we did not. No.
Is it something you're considering?
Well, we are a district heating company, so we don't have anything to do with electricity besides buying it to generate heat. So
it's
so
the reason why I'm asking is that also load is affected by temperature, so you can infer some additional data from how the electrical load behaves in real time and use it for thermal modeling as well.
Yeah. No, I don't think we're going to do any electricity modeling, unfortunately. But for sure, we're going to see a larger penetration of electricity in the district heating sector also in the future, because district heating is a massive thermal buffer, right? So it's ideal, but no.
Cool. Then I would say, thank the speaker again for their contribution.